Welcome to the training for the new production scheduling cloud application. This is the first of 12 presentations. The objectives for this lesson are to understand the business problems that production scheduling solves and being able to navigate within the production scheduling work area. Let's start with the overview. Unlike strategic or tactical planning applications, which typically consider the whole supply chain of an enterprise over a longer horizon, production scheduling focuses on a single facility within a shorter horizon. One of the main differences between tactical planning and short-term finite capacity scheduling is the following. Where planning determines which items shall be produced when and where and in which quantities, scheduling is concerned with how the production shall occur in detail, on which machines, and in which specific sequence. Production scheduling problems are inherently complex. While various resource and material constraints, multi-stage relationships, and changeover rules must be respected, it is important to do so with the key business objectives in mind. The fact that some of these objectives are conflicting one another is another challenge. Further, the scheduling process is cyclical, often following a daily cycle, which means that the schedule needs to be regenerated frequently. In addition, various execution events like machine breakdowns or hot orders or material issues may require to update a schedule on the fly. Any production scheduling model can only approximate the real-world manufacturing problem. It is clear that schedule quality is strongly dependent on the quality and accuracy of the input data. Therefore, data management processes should ensure that all data, but especially routing data, resource, capacity, and availability are of high quality. At the same time, it is important to understand that work orders are typically a result of tactical planning processes, which themselves are driven by a demand forecast and safety inventory targets, which have some inherent inaccuracy. Now let's go over some key aspects of finite capacity scheduling that must be kept in mind. Regarding data accuracy, as just stated, the work orders that have to be scheduled are at least partially the result of planning processes, which by nature have some data inaccuracy. In terms of problem complexity, the underlying mathematical scheduling problems belong to the class of hardest problems there is. This leads to the concept of a model. The representation of a real-world scheduling problem within a scheduling application is called a scheduling model. As such, it only approximates the actual real-world detail. Due to the nature of production scheduling business processes, with the need to frequently generate a schedule in fast manner, the usage of mathematically exact solution methods is generally not feasible. From this and the previous points, it follows that heuristic decision rules for schedule generation are usually not only necessary but also sufficient. Finally, when it comes to analyzing and adjusting a schedule after it was calculated, it is advisable to focus on the most important schedule quality aspects and not to chase false accuracy. In summary, all these aspects here should be kept in mind when addressing finite capacity scheduling problems. Let's continue with the next topic, the production scheduling business flow. Here, we see the key production scheduling tasks that repeat itself in each scheduling cycle. Note that the core tasks within that cycle are similar in most manufacturing environments. The main difference across different manufacturing environments and customers will be the default cycle length. While many customers have a daily scheduling cycle, others may follow a weekly cycle. The tasks in that cycle are the following. It starts with refreshing the production schedule with current data. Then a solution of the underlying scheduling problem is generated, which is the schedule. Next, the user analyzes the schedule and implements manual schedule changes as seen fit before releasing the schedule to the execution system, where it is then executed and monitored. As a brief demonstration, let's now navigate to the production scheduling work area and review some of the basic scheduling activities. After logging into the application, find the supply chain planning group and launch production scheduling. Here, we then see a list of schedules that are currently defined. From that landing page, we can navigate to another page where you specify the scheduling organizations. And that means that you can add organizations for which you want to be able to define schedules for. There are certain actions that can be performed on these organizations, and they relate to additional data maintenance, for example, for changeover rules. And we will discuss those in a subsequent lesson. From the list of schedules, you select the one that you are currently interested in to work with, and you can open it. This opens the schedule views, which consists of two sections. On top, we have a resource Gantt, and on the bottom, we have a tabular display of the, the work order operations as they are scheduled on a resource by resource basis. These views, they are connected to one another. So if you select one in one view, an operation in one view, then it will also be selected in the other view. There are various schedule analysis features that support finding objects of interest or problem areas for you to focus on. The first thing would be the ability to focus on very specific resources. In this case, I select a resource group with only these injection molding resources. This is relevant in cases where you have, many resources, a few dozen or more. Then you can drill to exactly those resources that you're currently interested in, evaluating. You can find work orders that have a specific code, and this is done via the filter by and filter value combination. So now I enter 205 as a string, and this now highlights all the work orders that have a 205 in their code. If I wanted to be even more specific, I continue with the matching string. And in this case, now I only have one work order left. So if I know the exact work order number that I'm interested in, I can enter it here and I find it immediately in the Gantt chart. You can use this filter capability also for produced items, and it behaves then exactly in the same manner. In addition, you have the ability to highlight the operations in a color that is associated with attribute values for attributes that are associated with these operations. For example, if I want to evaluate different thicknesses, then I see now that down here, the thickness 222 is displayed in this reddish color, while the thickness 111 is displayed in this light gray color. Uh, I can change that to another attribute of interest. And here it is a process color attribute that I'm interested in. In addition, you have the ability to find late work orders fairly quickly by activating the highlight late button. This can be the entry point for you to evaluate certain manual schedule actions or to, for example, uh, evaluate whether you want to run overtime, taking a weekend downtime out of the schedule or reducing it, corresponding to maybe working on a Saturday and so forth. And ultimately, you use various capabilities in the Gantt chart. For example, also to drag and drop operations as it makes sense. Of course, this is just now random here, uh, or to resequence operations. Now I moved this operation back by one, uh, and after these changes, you will run repairs, which implements those changes and commits them really to the backend database. Uh, it's recommended, and we will discuss that later on, to perform a repair after each manual schedule change. And after you completed your analysis and are happy with the changes you implemented, and you're happy with the schedule quality at this point in time, you can go ahead and release the schedule back to manufacturing by opening that release pane and sending the schedule via this release action. To summarize, in this lesson, we discussed the scope and complexities of scheduling problems, the relevance of high quality data, and how a typical scheduling cycle looks like. In addition, we had a brief look into the production scheduling work area.